audible?
Yes, sir. Yes, sir. Good morning, sir. Good morning, sir.
I'm at the desk. You can join in.
Yes, audible, sir. Manisha, can you switch off the music?
Yes, ma'am.
Okay. Good morning, Dilip. I think you are in mode.
Yeah.
Yeah.
Good morning. Good morning.
Yeah, good morning. Good morning.
How are you?
Fine, fine. How are you, Dilip?
Thanks. Good.
Good morning, ma'am.
Good morning.
Good morning.
Good morning, Dilip.
Good morning, Chitra.
Yeah, good morning, Dilip. I think my video was not properly.
No, it's fine. Hello, Mrinalini.
Good morning, sir.
Good morning.
I am
Hello,
trying to talk to our principal.
Okay.
Yeah.
Yeah, I mean, good morning.
Good morning, sir.
Hello, sir. Yeah.
Dilip is from IIT Mandi, sir.
Yeah, noted.
Okay.
Welcome, sir.
Hello, sir. Hello, sir. How are you, sir? Thank you.
Fine, sir. Thank you.
We start, Manisha.
Yes, ma'am.
If you want to wait for someone, we can
No,
wait.
sir. No, sir. We can start now.
Okay.
A very good morning to one and all present here. Learning gives creativity. Creativity leads to thinking. Thinking provides knowledge, and knowledge makes you great. Dr. APJ Abdul Kalam. Hi, we haven't met. I'm Dr. S.V. Jansrani here to anchor the conference. It gives me great pleasure in welcoming you all to the 5th International Conference on Computational Intelligence in Data Science, conducted and hosted by Department of Computer Science and Engineering, Sri Siva Subramanian Andar College of Engineering at Chennai in India. This is the second virtual conference, international conference, conducted by our department due to the prevailing pandemic condition of COVID-19. Hope everyone is safe and healthy in the end phases of the pandemic world and have taken precautionary measures to safeguard ourselves and the people around us. We welcome our principal, Dr. V. Annamalai, our beloved HOD, Dr. T.T. Mirnalini, and all the professors, faculty members, and participants for this international conference. Let us pray to the Almighty and pay respect to our mother nation. May I now request you all to raise for the Tamil Thai Varthu.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் மதனமென திகழ்வரத கண்டமிதில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை நுதலும் தரித்தனரும் திலகமுமே திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
I now invite our HOD, Dr. T.T. Mirnalini, to deliver the welcome address. Over to you, ma'am.
Okay, thank you, Jansi. A very good morning to everyone. It gives me an immense pleasure to start this auspicious occasion by a hearty welcoming to everybody here. It's my privilege to welcome all the delegates for the 5th edition of International Conference in Computational Intelligence and Data Science 2022. On behalf of Department of Computer Science and Engineering, a hearty welcome to our chief guest of this day, Dr. Dilip, Associate Professor from IIT Mandi. Dr. Dilip always with pleasure accept our invitation to share his knowledge towards computational intelligence. I think a couple of times he has associated with us in sharing his knowledge towards computational intelligence in machine learning with respect to images, text and speech in our research community, faculty and the research scholars. Thank you, sir, for accepting our invitation and being with us today.
Thank you. It's my pleasure.
Thank you. I would like to extend a cordial welcome to our beloved principal, Professor V. Annamalai. Sir, with pleasure accepted our invitation and he is here with us to deliver the inaugural address of this event among his busy schedule. Thank you, sir, for your presence. And a warm welcome to all the speakers and delegates across the world to share the knowledge in the field of computational intelligence and data science, to enlighten and give awareness to the research community around us in this particular field. And a cordial and joyful welcome to the faculty, staff, students, and research scholars of Computer Science and Engineering Department, and all the delegates who have participating in this conference across the world, nationwide. A warm welcome to everyone. In this particular event, we are eager to hear from the delegates about their ideas and innovations towards data science, computational intelligence, leading to the smart world. A detailed schedule of this today event is shared with everybody, and I would request all the delegates to express their views in the allocated time for discussion. And we do have various keynote speakers from industry and academia all over the world. They may join with us as per the schedule in the next session and so on. In this occasion, I would like to give a warm welcome to all these keynote speakers as well. And with this, I will hand over this session to the conference organizers for the further proceedings. Thank you.
Thank you, ma'am, for your kind words of welcome. I now request our beloved principal, Dr. V. Annamalai, to deliver the inaugural address. Over to you, sir.
Thank you. Good morning to all. I'm happy to note that the Department of Computer Science and Engineering is organizing the 5th International Conference on Computational Intelligence in Data Science. SSN is ranked 45th among all technical institutions in the country by National Institutional Ranking Framework. Such a position has been possible only by the philanthropic nature of our founder, ably followed by the relentless pursuits of our faculty and the achievements of our meritorious students. We have a strong research culture. There are several schemes to foster research among students. One such scheme is called STIRS, an acronym for Stimulus for Technological Innovation and Research among Students. Under this scheme, right from the first semester, students are invited to submit research proposals, which are then evaluated by external experts. And every year, about 150 teams win around rupees 40 lakhs worth of funding for their projects. This automatically brings in quality publications from students. Such outcomes will help the students in their career. Similarly, there is another scheme which helps faculty to get seed funding for any new ideas. Put together, these two schemes are supported to the extent of rupees 1 crore every year, year on year by the management. Maybe that is one of the reasons our environment is conducive for research. The theme of the conference, Computational Intelligence in Data Sciences, is very apt, considering the unusual situation that all of us are going through. Society as a whole is undergoing a massive transformation in this period of lockdown and social distancing. All practices have changed, enabled by the technologies that support remote access, work from home, and networking. Sharing of data and analysis of large volume of data has become the order of the day. The ability to comprehend and understand so much data becomes computational intelligence for people like us who are non-computers. Wherever there is data, there is the security issue of being hacked at any point in time. So cyber security also becomes a parallel technology to be nurtured, which has to be understood. So it is relevant that we all meet and take stock of development in data sciences to meet the future needs of the society. Many internationally renowned researchers like Professor Unica Mercier-Laurent from University Jean Moulin in France, Dr. Mesislav Ovok from Wroclaw University of Economics, Poland, Dr. Dominique Verdejo from Montpellier, France, Dr. Dilip from IIT Mandi, Dr. Sunanda Sengupta from Microsoft UK, and Dr. Vinod Patanjay from Wipro are all lined up to share their views. Good to know that select papers from this conference will be published in Springer journals. The conveners, Dr. Lakshmi, Dr. Priyadarshini, Dr. Madheshwari and Dr. Manisha, and the able guidance of Dr. Chitrababu and Dr. Mrinalini have done a good job of bringing all of you together. So I congratulate the organizing team and the Department of CSE for putting up such a good show. I wish all the participants a great learning and successful virtual networking. Thank you.
Thank you for the impactful and motivational words, sir. It was truly moving to hear. Now I invite our beloved Professor Dr. Chitrababu, who will speak about the conference. Over to you, ma'am.
Thank you, Jhansi. So respected Principal Dr. Annamalai sir, Head of the Department Dr. Mrinalini, the keynote speaker Dr. Dilip, the faculty colleagues, and my dear student friends, good morning to all of you. It gives me great pleasure to be part of this inaugural function of the 5th International Conference on Computational Intelligence in Data Science. The first 2 times it was conducted under the auspices of IEEE. Then it has moved to this IFIP Springer. It is going to be exactly 2 years since we had the initial lockdown due to COVID-19. I feel extremely happy that we all have collectively braved all the challenges and have come back to this present scenario where we are able to conduct physical classes again. How lovely it is to see the campus buzzing with enthusiastic students running all around. Hopefully next year we will be able to organize the conference in physical mode. The theme of the conference is actually artificial intelligence. So you might be wondering that artificial intelligence has been around since several decades back. Why now the theme is artificial intelligence? But the field has exponentially grown in the last decade. The deep neural networks, the availability of huge data sets, and the computational power from the GPUs, all of these together has really made a disruptive and transformative trend in every possible domain today. And that is when large amount of data is available, so you can analyze that data. Data science is actually a science that has been built around the data. So you can analyze the data and get some actionable insights, and which helps in decision making. So it started like that, that is for the businesses to actually get some such kind of actionable insights. And in fact, initially a decade back, no one knew where to look for valuable data. People were analyzing data under the lamppost. I have already told that story, that is, we don't know where the information is available. So we will be analyzing data whichever is possible to analyze. So that is how it started, like the person who was searching for his key under the lamppost. So that is why it is called as data analysis, data which is available under the lamppost. But we have evolved from that stage to today. Today, we have made huge strides in analyzing data, not only the kind of number data, but we also have data such as image, text, and we have the speech. All these are like multiple modes of data we are analyzing. And we have come up with several kinds of models which have been giving us enormous kind of accuracy compared to even human experts. So the deep learning has provided that sort of a leap of success in the last decade. And aren't we computer scientists fond of a lot of acronyms? So we have coined so many things like CNN, RNN, RPN, and BERT, and so it's like an alphabet soup. But essentially, that is, unless we are able to keep up with this rapidly evolving technology, soon we will become outdated. So every day, every week, there are so many publications which are coming up in this area. So everyone has to keep themselves abreast in this. So actually, I just wanted to talk about that is, while we are saying that AI has actually given something, a system which has defeated the Garry Kasparov in chess, or we say that we have built AlphaGo which has beat the Go champion Lee Sedol. Or we say that 2011 IBM Watson, it won Jeopardy game. So all these are intellectual pursuits. Okay, fine. So what is it doing for the common man or common woman in the society? So what kind of influential role AI can play to improve the life of this kind of common citizens? So what kind of environment and planet we are going to leave behind for our future generations? So can AI play a role in all these? Yes, I would say that if you look at whatever the United Nations has given as the Sustainable Development Goals, so for several of them, definitely AI can contribute to that. In fact, today morning, I was looking at the Hindu. So it says that our Chennai Corporation, so it has been receiving complaints from citizens through Twitter, and it is solving all that in a record time. That is so we have been facing like flood or this COVID-19. So if you are able to analyze these data and proactively, if you are able to prevent some of these things or provide response in a faster way, and that definitely improves the common man's life. So definitely AI has played a huge role, and it has to play a huge role. So in fact, if I'm going to touch upon some of the sustainable goals here, like industry, innovation, and infrastructure. So in industry, like manufacturing, or if you look at like how the smart buildings where energy efficient kind of things are built. So they're all, you are monitoring the energy usage, and you are able to have policies so that you are able to reduce the usage of that is unwanted kind of usage of energy. And in all this, behind the scenes, AI system is there. And also whether it is clean water or sanitation, and definitely healthcare domain, AI models are making a lot of improvement, like in terms of reducing the time in diagnosing diseases and quickly giving some kind of a treatment. And it will be a long shot to say that AI will remove poverty and AI will also remove hunger in this world. It will be like a very tall claim, but I would, since there are several students here in this participants, research scholars, and I would like to emphasize that it is not that far-fetched. That is, if you are able to assist all our farmers through smart farming, or if you are able to do something through, so how exactly you can forecast the weather so that they can actually plant the appropriate crops and have smart irrigation, then definitely we can have these kind of things also as our goals and objectives if we are able to use AI in a responsible way. So AI is, it's like a double-edged sword. So you have to use it in a responsible way. So we should not be proliferating our own biases through these kind of systems which we build. So if we are going to, because we are building data-driven models, if we are putting all our human biases into that AI system, then we are not doing any good to the society. So if we have to be conscious and sensitized to the fact that we should not be, whether it is gender bias or whether it is any other kind of bias, that should not go into your AI system. When you are building the AI system, you have to be very careful in choosing your data set so that it will actually be a, it will help in removing the inequities, not that it will accentuate already existing inequalities in our society. So I would also like to tell that critical thinking is very, very important. In fact, I again saw a quote by Bertrand Russell that was given by Abel Prize winner this morning in the newspaper. So when you have a perspective, it sometimes allows you to make irrational, rational decisions. So very nice way of putting it. So it is always good to be even critical of your own belief system often, so that you can redefine your belief system. So Critical here is not used in a negative sense, but you often go and examine your own belief system so that you can redefine that. So you all will practice that such kind of critical thinking, I hope. And now I would like to, as one of the general chairs, so I would like to talk about the conference itself. Like it was approved by IFIP, International Federation of Information Processing, and it is the technical committee TC12 that is the one which has approved it. On the whole, we received 96 papers, and all these papers were peer reviewed by 2 reviewers, and among them 28 papers have been selected for presentation and subsequent publication in Springer AICT, Advances in Information and Communication Technology series. We had 2 tracks of parallel workshops. Yesterday, one workshop covered image and video analysis. We had speakers from Niramai Health Analytics and also from academic institution. The track 2 was data science capstone, and this was completely done by Mohit Sharma, data scientist from Ericsson, Bangalore. And in today and tomorrow, between today and tomorrow, we have 5 keynote talks. Now, immediately following inauguration, Dr. Dilip will be giving on data science and its application. And the second keynote talk would be by Professor Unica Mercy Lohan and Professor Dominique Verdejo, France. So they are the chairs for this particular working group in IFIP. And they are going to talk what AI for global security. The third keynote talk will be on Dr. Sunando Sengupta, senior researcher from Microsoft. He will be talking on research trends in computer vision. The fourth one will be Dr. Vinod Patange, distinguished member of technical staff, senior member from Wipro. He will be talking on from features to embeddings, unified view of ML pipelines for text, audio, and image understanding. Then the fifth keynote talk would be Vici Floff Ovak, Professor Emeritus, Department of Business Intelligence in Management, Wrocław University of Economics and Business, Poland. He will be talking on honeybee democracy towards collective intelligence. So we have lined up a very impressive set of talks, and I hope that these 2 days will serve as a very important forum for researchers to engage in deep technical discussions on all these fronts. That is, not only your intellectual curiosity, but I want all of you to reflect so how AI can responsibly, ethically, and it should be interpretable, and it should be explainable, and it should be helping for the society in meeting all these sustainable goals which have been defined by the United Nations. Now, there is quite a lot of work that has gone into bringing this conference to fruition. So I appreciate the enormous efforts taken by the conference organizers, Priyadarshini, Manisha, Lakshmi, and Madheshwari. And I also would like to thank all the department faculty members in helping with the reviews and also with the logistics of this conference. And I extend my gratitude to Principal Sir for joining, and also for the management for their encouragement and support in conducting such conferences. Have a productive 2 days. Thank you very much.
Thank you, ma'am, for the very insightful speech. Yes, we do understand the responsibility of a teacher to motivate the students to use their AI expertise to serve a common man in spite of their technical pursuit. They should strive to remove the inequalities. Thank you for your very kind words, ma'am. Now I request everyone to switch on your camera to click a group photo. Thank you, everyone. Now I call upon the conference chair, Dr. K. Lakshmi, to propose the vote of thanks.
Thank you, ma'am. A very happy morning to all the respected dignitaries, participants, and my dear friends. On behalf of the Department of CSE and the 5th edition of ICCIDS, I express my heartfelt vote of thanks to our beloved principal, Dr. Annamalai sir, who has agreed to give an inaugural address amidst his busy schedule. Today, we had the opportunity to hear your thoughts, sir, which enlightened our minds and showed us a footpath in the path of the data science. Next, I would like to express my sincere thanks to Dr. T.T. Mrinalini, head of the department, for the wonderful welcome speech. Next, I thank Dr. Chitra Babu, Professor, Department of CSE, for the insightful background of ICCIDS under the theme of artificial intelligence. I wish all the participants to have an exciting and productive forthcoming session with us. I thank you all once again.
Thank you, Dr. Lakshmi. Now comes the most anticipated session of the conference, the keynote address by Dr. Dilip, Associate Professor of IIT Mandi, on the topic Data Science and its Applications. I request our conference chair, Dr. S. Manisha, to introduce the keynote speaker.
Good morning, everyone. It's my pleasure to introduce our speaker for the first keynote session, Dr. A.D. Dilip, on the topic Data Science and its Application. Dr. Dilip is an Associate Professor in the School of Computing and Electrical Engineering, Indian Institute of Technology, Mandi. He did his BE Computer Science and Engineering from Rural Engineering College, Gulbarga University, Karnataka, and received his MTech and PhD in Computer Science and Engineering from Indian Institute of Technology, Madras. He has more than 20 years of academic and research experience, and he has donned several roles in IIT Madras and other engineering colleges prior to joining IIT Mandi. His research interest includes pattern recognition, kernel methods for pattern analysis, machine learning, speech technology, and computer vision. He has published several research papers in reputed refereed journals, and our association with Dr. Dilip goes way back. He has given several talks in workshops, FDPs, and conferences in SSN and outside of SSN. Thank you for accepting our invitation, sir. We are happy to have you here with us for ICCIDS 2022 as a keynote speaker. We welcome you once again, sir. Over to you.
Thank you, Manisha, and thank you all for the warm welcome. And once again, congrats to all the organizing chairs and the conveners of this conference. Yeah, this is indeed a good conference which will be benefiting to all the research community. Okay, once again, thanks for inviting me and giving an opportunity to share my my knowledge, my views regarding the data science and related to that. Okay, thanks. Okay. So am I audible clearly?
Yes, sir. Yes.
Okay. And on one good note, so because I was just looking at the past, I see this conference proceedings. See, in 2017, I attended this conference as a tutorial speaker. So I still remember coming there and then giving the talk, which I really miss this time. Okay, so is the screen is visible?
Yes, sir.
Is the screen is visible?
Yeah, it's visible, sir.
Please stop me in between if any issues in network, which when I conveying the messages. All right. So yeah. So the topic which I wanted to share with you people, that's data science and its applications. Basically, when the main agenda of this talk, or what I plan to discuss, is that I'll just first half I'll just talk about what is data science and what are the things involved in that, basically starting from the data collection, pre-processing, why we do need to do the data pre-processing, and some kind of a descriptive analytics which acts as a basis for this pre-processing. And then comes the data modeling, where the predictive analytics using the machine learning. So all these concepts, I'm not going in deep of these things, but I'll just give the highlight that, okay, so what is the importance of each of these things in the field of data science? And also when we talk a lot about the artificial intelligence, machine learning, deep learning, we mostly looking into the algorithms associated to that. But before applying to the algorithms, there are a lot of things needs to be done with the data. So that is very essential for making it suitable for using this AI and ML applications or ML algorithms to use that. Okay, so I'm just touch upon some of the topics, some of the concepts associated to that. It's a very the preliminary level. It's not a very, it can be kind of a little general concepts which I'm sharing that. And then after that, I'll just touch upon a few of the applications of the data science, and two of them are prominently which we are doing in IIT Mandi, which is purely an application of the data science. Okay, so this is the overall things which I plan to share with you people. And in between, any of the doubt or any clarifications needed, so you're free to interact. You can ping and interact in between. Okay, so yeah. So now, so as you all know that the data science is truly a multidisciplinary field, right? It uses a lot of scientific methods, processes, and algorithms, basically to extract knowledge and insight from the data. The data could be structured and unstructured data. So we can see, still we can see that what do you mean by those things. Okay, so, but when you look into this, the data is available in every discipline. Okay, it is not related to, there's a misconception is there that the data science is purely a computer science related topic, and it's really it's not meant for the others and other thing. But this is that is a misnomer where even I keep telling to my students is that, so this data science is totally a multidisciplinary field where the data can come from the different fields. Okay, it could be electrical engineering fields or the civil engineering or from the science, basic sciences, or medical field, mechanical or computer science. The data is everywhere. Okay, so we will be looking into the techniques that basically we are trying to look into the techniques that helps to process this data and make some sense out of these things, and we can make use of those things for the benefit of the human being by applying that in the various applications. Okay, so applications in each of the fields is enormous. Okay, the few I just mentioned, and not going into each of those things, but just for the mentioning I given there. So the data is everywhere. That's what I'm trying to highlight that. But so when we talk about the data science, it unifies various concepts. It unifies the concepts from the statistics, data analysis, machine learning, and of course the computation is required in order to compute, in order to do the digitally process this data. All these things we make basically to understand and analyze the actual phenomena that is present in the data. So most importantly, along with these theories from the mathematics, statistics, and computer science, okay, so most important thing is also a part of this data science is the domain knowledge from where the data is originated. Okay, so that is the beauty of this area where it is not related to the one discipline or one concept. Okay, it is a unification of various concepts, right? So even if it is a civil engineering person, okay, so a lot of data that is there in their field. For example, there's a lot of experimentation they do in which they collect the information about the strength of the materials they're using for the constructions or the bridge strength and all the things, right? So this data, which can be usually processed and then can be used to make some kind of an analytics or the predictions on how good the strength is. Okay, without connecting some of the experimentation, can we predict what could be the strength of the material or how much it can withstand the fatigue test and all those things. Okay, so in this particular case, what I mean to say is that, so they're having the concept of the mathematics and machine learnings and tools, the application in the different areas. Okay, so that is very enormous. And having these data science techniques, knowing that along with the domain expertise, they can do a lot of things can be explored and in the respective fields. Okay, so that's exactly the things is the knowledge and also the field of the research is going into that, where the interdisciplinary research is a primary thing. And thanks to this data science and these techniques, which have been applicable to everywhere. Okay, just looking at the bigger picture where the data science is present. If you look into that, as I was mentioned, it is a culmination of the theories from the various fields: mathematics, computer science, machine learning, and statistics, and the data processing. And most importantly, what you're seeing over here is the domain expertise. Okay, so it is very important that given the data is everywhere, it's available everywhere, right? So without understanding what domain it is coming from and then what is the meaning of that data, okay, so applying all these data science techniques will not be any useful. Okay, so the expertization in the domain from where the data is originated, that plays a very important role in order to extract most out of the data and then make some useful information out of it. Okay, so that is the data science. Okay, so now if you look into that, the central concept in the data science is to gain the insight from the data and use it for the application. Okay, now if you look into the various tasks or various modules, which you can see that it comes under the data science, is that, of course, first thing is the data, how you collect the data. Okay, so there are different forms of the data is there, and depending upon that, the different ways the data can be collected. Okay, and all this collected data will be stored in the database. Okay, and the stored data and also the databases, the type of the database technologies which is used for storing, it depends upon the type of the data which we were collecting. So once the data is there in the database, we can't use them in the raw fashion to make any analysis or make any useful information out of them, because they usually, because of the kind of a inconsistency or kind of a impurities that is included while collecting the data, so the data is not very clean. Okay, so you need to apply some kind of a data cleaning and cleansing techniques to remove some of the impurities, some of the missing values, or the remove some of the noise present in the data, and to make the data a good quality one. Okay, once the data is being cleaned or cleansed, okay, then it can be used for analyzing the data and get the most useful information from it, where we can get the statistics that's from the data or the important characteristics from the data to do some kind of a predictive analytics can be done from that. Okay, all these things comes as a part of the data pre-processing. Okay, at the same time, so we can also do the predictive analytics by learning from the data. So for these cases, so we need to reprocess the data or transform the data into the specific form, so that the machine learning algorithms can use them to model the data, and one can get the inference out of this machine learning model. So in that way, overall, if you really see that data collection, data pre-processing, and the data modeling using the machine learning, all these things are very well connected, and then each one is complementary to each other, because basically in order to success in making the machine learning algorithms to make a good inferences, for that a good data is needed, and how well the data is collected, it also matters, and then how well the data is processed, is also matters here. Okay, all these things are related things. Okay. Okay, what I'll do is that, so I'll just briefly touch upon each of these components: the data collection, data pre-processing, and the data modeling. I'm not going into each of the techniques and explaining them, but I'll just touch upon them, that what are the things are there and why they are necessary in doing these things. And then I'll go for an application where all these things are taken a part of that. Okay, this is how I organized this talk. Okay, so yeah, so if you look into the first part, it's a data collection is concerned with. So briefly looking into that, so data can come in the different forms. Okay, if you think about that, so the different forms of the data it requires the different ways of collecting them. And at the same time, once they collect, the different forms of storage solution is also required to store. Okay. So if we look into the various ways, so you can see, usually you can see it in the two ways the data can be collected. Either the data can be collected in the form of a survey poll or the polls. Okay, that's one way of collecting the data. And another way of collecting the data, it would be doing some experimentation, and as a result of the experimentation, collecting the data. Okay, the experimentation, in the sense, the simple thing is that in the laboratory there are a lot of experimentations you do that. Okay, and the result of the experimentation, you know that what is the ingredients you put it for those experiments, and what is the output is coming from, and if you vary the inputs and what is the outputs are again. So when these experiments are done, okay, so all the recording of each one of those things, that is what I'm telling from the experiments. It spreads in a different way. Okay, so varying from the experiment which is done on the lab till the outside where we are collecting through the sensors and all the things that comes under that itself. Okay, so accordingly, if we really look into that way the data is being collected, according to me, I organized into the three forms. Okay, but there could be many things one can organize it, but just it is my view where in the purview of my research and then area, how I collect the data. So in that way, I just grouped into the three ways. So one of the things is that data comes from the surveys. Okay, usually the data which is collected from the surveys is in the form of the textual data, or sometimes the numerical data. So sometimes it's both mixed form. Okay, so an example of that data which is collected on the survey is given over there. Actually, this is the data which we collected 2 years back when the lockdown has been imposed, and then we went for online classes. It was totally new to us. We do not know the logistics to how the online classes will be get into that. And then if we conduct the online classes, whether the students have the enough resources to receive the lectures and the and participating in the online discussions. Okay, so that's why some of the poll we have conducted. So the poll, the main questions is that basically this is for my course where almost 250 students were there. So need to conduct the class for such a large class in the online mode. So we first conducted a poll to see the logistics for that thing. So where we asked the three main questions, whether they have the laptops or test tablets there along with that, because this is a first year course where most of them are very new to the environment, new to the IIT system. So first question was whether they have the laptop or tablet that helps to view the videos. And another question was that what type of the internet connection they have. Do they have 4G connections, 3G, or very bad network connections, or no connections at all? And another thing is that do they have any laptop or the desktop to do the programming assignments? Okay, so this is based on the poll. We got a lot of information and statistics, and according to that, we went ahead with our initial online classes and everything. So just to point out what I'm pointing out with respect to this is that, so this is the one way of collecting the data through the survey, through the polls. Okay, and a lot of insights we got it from that how many students are really in trouble, how many students are actually having the good internet connections, and how many have the difficulties. All these things can be inferred from this data. Okay, so this is what I was pointing out. And the second type is that data that is obtained by entering onto the database systems. Okay, there are some physical systems, several physical systems are there. For example, take the case of the academic, the automation system. Whenever a new student enters into the institute, so his records will be entered in the database, right? So, and in similarly, when the faculty comes in, his information will be recorded, and that record, and also all the activities of the automation of process in the different sections. So that has been entered time to time whenever the data is available. So this is one form the way the data is entered, and then the database contains all the information of the students, all the information of the faculties and staffs in the college, or all the information about maybe the financial information or academic information. All these things have been entered and stored in the database. This is one way of data that is present over there, okay, or the collecting the data. Okay, and a third way of collecting the data is more from the experimentation side. This is where the data is in the form of the signals. Okay, it comes from the sensors, which is collected, or it can also be considered as some of the signals. The signals could be the resultant of some of the experiments. Okay, so all those things falls under that cases. Okay, so for example, is that so when you collect the speech data through the microphone, so that's a sensor. So from that is a one form of a collection of the data, and the sensors, the visual sensors like cameras, we can collect the images in videos, and from the various sensors which is associated with the environmental parameters like the temperature sensors, pressure sensors, the recording the informations of the temperature, pressure, all these things. This is the data that comes from the signal. Similarly, the collecting the seismic data related to the earthquakes or the EEG or the biotype of the signals. So all these are the resultant of some kind of an experimentation, some kind of a data which is collected through the one or other way of the sensors. Okay, they're all in the form of the signals. Okay, so these are the three major categories which I consider in my area as some kind of a data, different ways of collecting the data. And in each of the cases, the form of the data which is collected, that will be different. And based on the objective of the task, the way the data collected will be changing. And also in each of the cases, the kind of a data which is collected also will be different. Okay, with reference to that of the type of the data, okay, based on the way they have been organized, okay, usually we have the three forms of the data. This one is what is called the unstructured data. So basically it is the rawest form of the data. That means, so any type of the files like your text, images, sounds, videos, all these are kind of a, what we call it as a unstructured data. So I'm not telling that, okay, image is a 2D data and other thing, why it is not unstructured. I'm not saying about that. So what I mean to say is the structured or unstructured is that how they're organized. Okay, and each sample of the images, how they are different. Okay, so in that way I'm talking about that. So usually they are stored in this unstructured data stored in the form of some kind of a repository of the files. So for example, we consider any of the well-organized directories in the computer hard drive. So that's a kind of a example of your unstructured data. It directly contains of the different images. Okay, and that is the collection of your unstructured data, what I am talking about. Okay, and on the contrary to that, we have the structured data. So we call the data as the structured data when the data is in the form of a tabular form and where in the form of the rows and the columns. Okay, and each row is having the ordered, finite ordered list of the elements. Okay, a sequence of elements that will be there. Okay, and each column indicating to a very specific type of the data that is it's associated to an attribute. Okay, so if you look into an example here in the table form here, so every row indicating one record or the of the data, and that is the sequence of data that is there in one row. And if you look into each column wise, and each column specifies a well-defined type of the data. For example, first column indicating the date or time. Okay, and the data type associated with all the entries in that particular column. Okay, that's the same thing. That's a well-organized. That's it. That is why this is structure. Okay, and similarly, if you consider the third column, it is a pressure. So all of them will have the same type of the data. Okay, what is considered here. So it is the unit considered as a Pascal, and then the range and metadata associated with that also been associated with that. Okay, that's why this is a kind of a structured data. And usually these structured data, they're stored in the form of in the databases. The database could be a spreadsheet like your CSV format, comma separated value format, or any of the relational side like your Oracle, DB2 or something. Okay, all right, or MySQL and other thing. All right, okay. So just a quick question. So is it, am I properly audible?
Yes, sir.
Okay. Oh, okay. All right. So fine. So right. So please ping me if any issue in the audibility is concerned. Okay.
Sure, sir.
Okay. So this is the one type of that structured data what I'm talking about. And third type of is what is we call it as a semi-structured data. This semi-structured data is somewhere in between the structured and unstructured data actually. So basically here, there's a consistent format is defined for the data, but there is no strict structure like the same entity will have the same type of the data and other things. It can have any different type of data, or it can have the incomplete data. Also, it can have that. Okay. Usually, the data types, data forms like your XML, JSON format, all these things are what it comes under the category of the semi-structured data. So all the three things, if you really see that, the way of the storage which is done for each of them will be the different things. Okay, one is the relational databases, structured data set, and then the semi-structured data set is in the form of the XML or JSON format, and then in the unstructured data, they're in the form of the files. Okay, so that's what I was talking about. That based on the organization of the data, the format is different. Okay, and each of the cases, the way they have been collected and stored, that also going to be changed. That's the point I was just highlighting. Okay. Now, once you have the data and then the data is in your database, so it's important to process the data. Okay, and that is what we do before we do any of the analysis of that. Okay. So why do this data pre-processing is needed? What is the importance of it? So usually, any real-world data when you collect it, so that is tend to incomplete, it tend to be noisy, and it tend to be inconsistent due to the various reasons. Okay, so one thing is the data is huge when it's collected in the real world, so they tend to become incomplete, noisy, and inconsistent. And at the same time, data, in many cases, data is originated from the multiple heterogeneous sources. Okay, it is not originating from one source, it is originating from the multiple sources. For example, if you consider that I wanted to build a weather station in the maybe in the IIT Mandi campus itself. So in that case, I need to collect the temperature, just as consider only the temperature is the parameter. So I need to collect the temperature. So for that, I need to implement or put not only the IIT Mandi, entire Mandi district, if I consider that. So then I need to keep the temperature sensor in every village and every town in the or every place in the IIT Mandi, in the Mandi district. Okay, and from each of the places, the information will be collected. So here, the heterogeneous sources is that. So because the data is not coming from one source, I am keeping the sensors in the multiple sources, and then I need to collect the data from these multiple sources. And this is a simple example I give. So suppose if I want to take one more information about the atmospheric pressure, then I need to keep the pressure sensors along with that. Now, the number of sources from where the data is coming is also going to be increased. Okay, this is what I was talking about. This is a common thing when any of the data is collected from the real world. Okay, so that's the reason why this pre-processing is very important to clean the data. So that's mainly the main reason is that if the data is not being cleaned, then there is no guarantee that the quality of the data what is being there to analyze, that's no guarantee there. Okay, so the low quality data, it always leads to a low quality in the analysis results. And at the same time, these low quality data, when it has been put to use and when the analysis results have been given, the users who are depending upon this kind of an analysis, they try to untrust the results because the source where this analysis has been happened, the data is not of the good quality, then definitely the analysis obtained from that is also untrusted. Okay, so that is a problem happens. And at the same time, when such kind of a data will be used for making some kind of a predictions or learning some insights from using the machine learning algorithms and other AI techniques. So at that time, so the AI techniques, they when they use such low quality data, the resulting the inferences will be unreliable. Okay, so keeping all these things, it is very essential to pre-process the data. Okay, and important components need to be addressed is that, say, how do you address this, clean the data when the data is incomplete, noisy, and inconsistent. Okay, so for this, you need to understand what do you mean by the incomplete data, what do you mean by noisy data, and what do you mean by the inconsistent data, and what is the reason for each one of these things. and then, okay, and that is the important thing, and that is what we're going to see in next 5-10 minutes. So the incomplete data, so that means that as the name itself suggests, so I'll be limiting myself to the structured data, where the data is in the form of your relational databases, okay, each row indicating a record, okay, and each column is associated to a specific attribute, okay. So if you consider in that set of the data, so in incomplete data, so many of the records will have no recorded values for several attributes. That means the several attributes will not have any values in that, okay, and such data we call it as incomplete data. For example, I am collecting a data about the environmental parameters like the temperature, humidity, and the amount of rainfall happened from the different sources, okay, different locations. All right. So when I collected here, and then the data which have been shown there here, right, on the different dates has been collected from the different stations. It's been collected, and for some of the cases, so the temperature information may be may not be recorded. It has not been recorded. In some cases, the amount of rainfall happened is not being recorded. Okay, so when such things happens, when there is no recorded value in the several attribute, that is a scenario we call it as it's an incomplete data. All right. So what is the reason for this incomplete data? There are many reasons are there. Okay, depending upon what type of the data has been collected, either it may be due to the operator's fault, or the user forget to fill the fields in some kind of a polling in other cases, or in kind of a census cases, there may be a fault in the device which is recording the things, or there may be so since we are collecting the data from the multiple sources and then they need to be transported to the one common region where it has to be coherently, the data has to be maintained. At that time, during the transmission error, due to that, the data might have been lost. Okay, there are many such things. Okay, so will lead to that kind of a incomplete data. That's the reason why I was telling that the data which is collected, due to these reasons, it could be a incomplete data. That's a that needs to be processed. Okay, and when it calls, then what do you mean by the noisy data? So in the noisy data, it is not an incomplete data. That means that all the recorded tuples or the records, the data has been recorded there, but some of the values which is recorded will be incorrect values. Okay, they are not null, they are not incomplete, but they are noisy. That means that there is some incorrect value has been recorded in some of the attributes. Okay, what is the reason for that incorrect values being recorded? So again, it could be either the human or computer error, or the instrument which is collecting the data, the sensor, it could be faulty. Okay, or when the data is transmitted from the source where it is generated to the storage devices, during the process of transmission, there may be some kind of an error. Due to that, it could be there, or there should be some kind of a technological limitations, like when the data is recorded, the buffer size is low, or any other limitations. Okay, instead of completely recording the data, it might have corrupted the data due to those things. Okay, so these are some of the reasons why the incorrect value could have been recorded when the data has been collected. And the third thing, which is common thing, is the inconsistent data. Okay, so here again, the data has been recorded. Okay, there's no problem in missing of any of the values here. Okay, or there's no problem of the noise or the incorrect value has been stored, but there are some inconsistencies or the discrepancies will be there in the stored values of the certain attributes. Okay, so some of the reasons for these inconsistencies are, one of the reason is because of the name conventions may lead to the data. Okay, another thing is the data code used to mismatch in the values which has been written in the databases, but it's a true value, it's an actual value, but there is a mismatch in the data codes which is being used. And then another thing is mainly due to the inconsistent formats of the input fields, okay, such as date formats and other things. Okay, so if you look into these examples as these things, okay, so the name conventions in the sense, so when the data has been collected, suppose you think that, okay, data is collected from the multiple sources. In one source, the data is stored with the attribute name as a whole number, it's a roll number, the student's information is taken, and in another source is called as the registration number. Okay, when we combine this data, okay, there's a confusion for the data that, okay, whether this roll number and registration number are the same. For the human beings, we know that, but for the automatically, when we combine it, the computer can't distinguish between them. Though the data is correct, so this is the discrepancy. Because of that, the data might be inconsistent, and as a result, so both roll number and registration number may be stored as two separate columns. Okay, that's the thing. And all, when you are collecting the temperature from the different sensors from the different locations, in one location in its local storage is stored in the form of the temp, and in another storage is stored in the form of a temperature. Okay, when I combine it, it may be considered as two different attributes. Okay, and another thing what I was talking about, that's a data code used. That is that suppose in one, there are different units of measuring the some of the data, right? Suppose the example is the temperature. It can be either measured in terms of the degree centigrade or in the degree Fahrenheit. Okay, if the two sources where the temperature has been recorded, in one source is called as the degree centigrade, and in another source it has been recorded as a degree Fahrenheit. When you combine these data, so there the values over there will be totally inconsistent because the units which is used to represent them are different. And at the same time, in the input field formats are different in the different sources. Okay, typically it happens during the date cases. In one case, we use it as a DDMMYY, or in other cases represented as a DMM/DD/YYY. So these two things, the format differences will happen. So that leads to the inconsistencies. So typically, this inconsistency of the data happens when the data has been used during the when we are integrating the data from the different sources. Okay, so this is what exactly the example I was talking about. While integrating the temperature, which is recorded from the different locations, if the name conventions are different, or the there is a data code which has been used are different, then the data, when it's been integrated to form one common data, so at that time there will be a lot of inconsistencies that happens. It happens. Okay, and this are all the issues that is available, and in order to address these things, the pre-processing is very essential. Okay, so that is what we are talking about, that data inconsistency. How do we address these inconsistencies or these or the missing values and all the things? So this is where the data pre-processing involves, and the various tasks like data cleaning, data integration, data transformations, data reductions. These are the different pre-processing techniques. Okay, and these things, some of them will address to addressing the issues of the inconsistency in the data and to make the data clean. Okay, so in order to do this data pre-processing, usually we do the descriptive data analytics, which acts as a foundation for this. Okay, what do we do in the descriptive data analytics? Basically, so we studying the general characteristics present in the data, or the statistics of the information that's present in the data, and identify the noise. So these indicating the descriptive data analytics. Okay, it talks about what characteristics the data is having and statistics of the data. All right. So this helps in some way to address the some of the issues of the data and pre-process it to make it clean. Okay. So what are the data characteristics we talk about? So that's nothing but the statistics of the data present in the data. Usually, we look into what is the central tendency of the data. All right. Or another thing is the dispersion of the data. What do you mean by central tendency? Basically, the center of the data. That means, so usually it is measured in terms of the mean, median, mode, right? And similarly, the dispersion, it gives you the what degree with which the numerical data tends to be spread, right? So usually it is measured in terms of the range, minimum values, maximum value, quartiles, interquartile range. Okay, so the 5 number summary, standard deviation, these are all the different ways of measuring the dispersion or the spread of the data, numerical data that is present over there. And these helps us to identify some of the issues. Suppose, for example, if you're having the fields where some of the entries are missed, okay, usual things what we consider is that take the mean of the values or the center of the data, and then we replace those values with respect to center values. Okay, so that is the example what I was talking about. Then that way, this descriptive analytics helps in addressing the pre-processing. Okay, and also most importantly, this descriptive data analytics, it also gives you the data visualization or kind of a understanding the what is the data is all about. And this understandings, once you get it, then you can address how to address that inconsistency in that data and how to address the missing values and how to clean the data and all the things. Okay. As an example to this descriptive analytics, if I consider, so as I mentioned, when we conducted this survey and for designing the online lectures for a particular course, okay, the three questions which I mentioned, right? So this is one of the visualization which tells that, so do you have the laptop in the or the tablet to help to view the videos? Okay, so you can see that, okay, this visualization says that 97% of the people are having the laptop or tablets to visualize the things, and few of them doesn't have. So this helps us to, this is a characteristic of the data which helps us to take the measure. So what can be done for that 3% of the students? Okay, so that they can be a part of the online courses. And at the same time, what kind of a network connections they are having. So it's a very diverse thing. So it can be seen that there are 56% of the students are having no issues, but rest of the people are having some kind of a limited connections. Okay, and that is the things which helps us to take the necessary actions to do that. Okay, this is one of the way you can say that this is one of the descriptive analytics. So what we were talking about, which helps us to understand what is there in the data. Okay, and similarly for programming, anybody is having a laptop or other things, it says that, okay, around 5% of the people doesn't have that things, and that means that we need to take a special care to them. Okay, this is a simple examples which I was mentioning, that what is descriptive analytics, so which tells about. Okay, and we're coming to this different techniques of data pre-processing, as I was mentioning about the data cleaning. Okay, so data cleaning, it is basically, it involves in various operations. What is that? Basically the data cleaning is applied to identify the missing values in that, and then fill the missing values. Okay, and also they remove the noise and correct the inconsistency that's present in the data. All these things are done by the data cleaning techniques. Okay, so usually, if you really see that when the data is being given, when the analysis, when we do that, so it says that around 80% of the data scientist time goes in collecting the data, and it goes in pre-processing and cleaning the data, especially the cleaning the data. It is a huge, enormous task. Okay, so many of the times when we do the machine learning techniques or machine learning things, we just tend to take the data and we just directly apply that. But actually speaking, to prepare a data which is most suitable for doing any of the machine learning activities, okay, so for that, a large amount of time will be spent to make the data clean so that it can be used for making some useful inferences from the machine learning. Okay, that's the reason why we are saying that 80% of entire life cycle of the data science things, starting from the data collection till getting the inferences from that. Okay, in that 80% of the time it will be spent in making the data clean and making the data suitable for the task. Okay, that is what is involved there. Okay, and the second technique is what we call the data integration. So this is the technique what I was telling, that it is where when the data is collected from the multiple sources, so it is necessary to merge the data from the multiple sources to form a one coherent data source. This is a very common thing that is to be done whenever there's been application. When we collected data is collected from the multiple sources. For example, there's the same thing, environmental parameters. When I'm collecting it to set up a weather station, okay, so the temperature sensor collects the temperature information, pressure sensor collects the pressure information, rain gauge records the amount of rain happened in these things, and each one is the different sensors. Okay, and each one are placed in the different locations. Okay, and in that location, locally it stores the information individually. Okay, when you want to process it, when you want to see this data, you need to port all this data to one common location, make it a one common coherent data source. And that's where we need to integrate all the data from the different sources and different sensors to make one coherent data source. This is what is called as the data integration. Okay, and in that data integration, one has to take care of the inconsistencies in all these things has to be addressed. Okay, that is where the data cleaning comes into picture. Okay, so it doesn't mean that okay, data integration and data cleaning are done independently. They also do both go hand in hand. Okay, this is what I was wanted to highlight. For example, if you look into here, this is what is the typical example of the data, which has been a coherent data source has been formed after integrating. You can see here, this is the location ID T10. What you are seeing here, these 4 or 5 records came from the location ID with the different location, different station. Okay, similarly, the T11 is data came from the different location, and in that location, temperature, humidity, rain, these informations are recorded and stored separately. Okay, when we combined all of them and the data integration has been done, each of those entities have gone into a separate columns. Okay, and the station ID is also been included, and according to that, the data, the date at which is been recorded is also been recorded. Okay, so this is the process. This is the resultant. This data piece of data, what you're seeing here, is the resultant of the data integration, where the multiple sensors data has been recorded and they're integrated from the multiple sources. Okay, and another kind of a data pre-processing techniques, what I was talking about, the data transformation. This data transformation is basically to transform the existing data into the one common format. Okay, and this kind of a data transformation, typically it is useful for making some kind of a processing, and especially when the machine learning algorithms has to be applied onto the data. In some of the techniques, they need the data to be transformed into a specific common format. Okay, so typically, if those who are working in the machine learning, you know that when the data is given, you often do some sort of a normalization, some sort of a standardization, or this Z normalization. We do that. Okay, why are we doing that? Basically, some of the machine learning algorithms, specifically which involves the distance measures to compare the pair of data. Okay, they work well when the data is standardized or the normalized. Okay, so that's the reason why one of the pre-processing techniques, what in general we call it as a transformation, is needed to make it more suitable to get the more reliable inference from the various machine learning. Okay, that is the third technique which I was talking about. And then fourth one is what I was talking about is the data reduction. Okay, so usually there's a huge, when the data is collected, the data might be very huge. Okay, sometimes for doing a specific form of the task, so all entire data may not be required. Okay, so usually this data reduction is applied to reduce the representation into a smaller volume, such that even though you are using the smaller volume of the data, okay, so it still produces the same analytical results. Okay, so that is what I was talking about, the data reduction. There are different ways one can do this reduced data reduction. One of the ways is that what we call it is aggregation. Say, for example, so consider that you are having the data of the sales of a particular product. Okay, the sales happens every day or every hour. Okay, and every hour the sales of the different products has been recorded. Okay, so we can say that at the granularity of every hour, the sales, what amount of sales are happening there, that data has been collected. But to do some of the processing, I want to see that the data at the granularity of the every month is required. That means every month, what is the sales happening? Okay, so at that time, so we try to aggregate all the sales that is happening in 1 month, in either by adding all of them or taking the average of the sales in the thing, and then we reduce the data by this aggregation in the form of at the granularity of monthly records. Okay, so that is what we call it as a reducing the data in terms of the aggregation is concerned. And another thing is that this is with respect to the records. And this another case is that we have the several attributes in the data, and some of the features, they are irrelevant and then they're redundant. Okay, so through the correlation analysis, identifying which of the features are irrelevant and which are not redundant, and removing them and retaining only those which are relevant for the task. So that is the other way of reducing the data. And another way is by using the dimension reduction. Okay, like your principal component analysis, autoencoders. So these are things one can apply to reduce the data. Still, it consists of the important characteristics what the data is having. Okay, so these are the different pre-processing techniques. Some of the pre-processing techniques are used to clean the data. Some of them are used to transform so that it can be more suitable to make the better inferences from machine learning algorithms. Altogether, all the things are essential before we go for doing any analysis or any predictions. All right. So this is about what I was talking about, the data pre-processing. And most importantly, as I mentioned, so all these techniques are not mutually exclusive. Okay. They may work together, or okay, some of them work together. Some, okay. All right. So but each one of them complementing to each other. That's very important. Okay. So now the third part is that how we can model the data. Okay. Now we have pre-processed the data. The data is clean now. We need to analyze it. And one of the way of analyzing is performing the predictive analytics. Okay. So predictive analytics, that means that so we can use the machine learning algorithm to learn from the data and extract the knowledge. Okay. So that is where the data modeling comes into picture, where the machine learning algorithms are used for predicting from the data. Okay. What could be the future temperature, or what could be the future sale? Okay, so given the temperature and the atmospheric pressure, what could be the amount of rainfall we can expect there? Okay, so these are the kind of predictions what we can do. So these are the things we can do it from the data what is available there. Okay, this kind of inferences we call it as a predictive analytics. Okay, so basically it is used to identify the trends in the data, correlations or the causations, by learning the patterns from the data. Okay, so moment we learn the things, the algorithm that helps here, they are the machine learning algorithms to do that, to predict the data. So there are different kinds of predictions or the predictive analytics one can do there. So it involves the tasks like the classification task, we usually call that. So where we try to predict the categorical labels, which groups, which category the data belongs to. Okay, for example, if the data, this is the diagnostics of a person is being given. Okay, predicting whether the disease is present or not. Okay, so that is the classification task, where the category is presence or absence of the disease. So we're trying to make to predict the categorical labels. Or the another example is the predicting the category of the diseases according to the symptoms. Okay, so what type of the disease it is. Okay, that is the category we are talking about. And then another task is called the regression. The regression usually we call it as a numeric prediction here. What we predict is a continuous value we are predicting it. Okay, so here the example, for example, is given the moisture content in the atmosphere, temperature, the soil content, okay, and the acceleration in which the soil is moving. Based on this information, if you predict what is the amount of rainfall happens, okay, that is the numeric prediction or the regression task. Okay, or based on the temperature, humidity, pressure, okay, predicting what is the amount of rainfall happening. Okay, that is the regression task. Okay, so this is the predictive analytics from the data what we are talking. Apart from that, there is one more task that is what is a clustering, where we group the similar patterns, okay, based on the similarity that is present in the data. Okay, for example, from the sales data, so grouping the similar items that are sold by a particular representative. Okay, so that is one kind of a grouping. Another thing is that if the records of students have been maintained, okay, from all the records of the students, grouping the students according to the region of India that's from where they belongs to. Okay, these are some kind of a grouping or the clustering task which we talk about. Okay, for all these tasks, okay, so the predictions are done based on the learning certain pattern from the data. Okay, when you talk about the learning from the pattern from data, that's what we usually call that. The machine learns automatically from the data. Okay, the regularities of the similarity that is present in the data. All right. So there are two types of the learnings the machine does from the data. One is what is called as the supervised learning, and another is what's called as the unsupervised learning. All the tasks which I discussed, the classification, regression, and the clustering, they fall to one of these two categories. Okay, in the supervised learning, the data which is used for learning, okay, so that is, we call it as a labeled data. So basically, each example in the data is paired with the, it's considered as a pair of example. What is the pairs here? One is the input example and another is the desired output associated. Okay, in the supervised machine learning, basically it tries to learn the association of the input variable with its desired output variable and tries to learn what the association between them. Okay, and this kind of a learning, we call it as a supervised learning, and this is exactly the thing happens in the tasks like your classification and the regression. In both the cases, classification, it tries to learn the association of the input variables with respect to its class label. And similarly, in the regression, it tries to learn the association of the input variable with respect to the variable, which is the predicted variable. Okay, that is what is we call it supervised learning. In the unsupervised learning, usually data used for this learning are not labeled; they are unlabeled actually. Basically, based on the similarity that is present in the data, you are grouping them or partitioning the data into the different groups. Okay, so this typically the classes, the task like your clustering and association that falls under these. Okay, so this is about the what we call it as a machine learning, which involves in doing some kind of a predictive analytics is concerned. Okay, so just to summarize the things what we have seen before going to the applications is that, so what we have seen is that so we know what is the data science and what are the things involved over there. Okay, and at the same time, so it involves the different steps. Basically, you collect the data, you need to pre-process the data, and you need to analyze it. Okay, analyze the pre-processed data. And there's a kind of two types of analysis one can do that. One is the descriptive analysis, where you're taking the statistics that's present in the data or characteristics that are present in the data. That's one thing. And another is the predictive analytics, where you can use the machine learning techniques to learn the patterns from the data and then predict what is important. Okay, that is what we are seeing. Now, what we're going to see, some of the applications where all these things which I mentioned will be a part of that. And then you can think about what are the different predictions, what one can do with respect to that. Okay, before going into the some of the applications which I'm going to discuss. Okay, so if you have any questions or any doubts, so I'm open for the question. Yes.
Participants, if you have any queries, please, you can ask.
Any queries are there? Is what we discussed, is it fine with all of you?
Yes, sir. Perfect.
All right. Okay, so the next 20 to 30 minutes we'll spend on some of the applications. If you really look into the application, as I mentioned, the data is there in every field. Okay, and there are enormous data that is present nowadays. Okay, and there are a lot of applications are around this data, but I will concentrate on the 3 applications here, and we'll see how each of the techniques, how each of the things which I talked about are really relevant there in each of those applications. Okay. Okay. So the first application which I'm considering here, this is related to the in IIT Mandi. We have set up our own small weather station, where that station, which collects a lot of environmental data like the temperature, humidity, pressure, amount of rainfall, and all those things, etc. Okay, and the higher view of this IIT Mandi's weather station, what you are seeing here. So this is a courtesy of my colleague, Dr. Siddhartha Sharma. He is an IoT and communication expert. Okay, and he has his project. This is, and then he has set up this weather station. Okay, if you look into that, the data collection process is concerned with. Okay, so each one of these boxes, what you are seeing here. So these are the different the Raspberry Pi based modules. Okay, on which the different sensors have been mounted, and each of these sensors have been deployed in the different locations in the campus. Okay, and each of these sensors or each of these, there are two ways and there is a central repository where the collected data will be stored in a coherent fashion. For that, the SQL database being used, and then for the web access, where the PHP has been used for that case. Okay, there are two ways the database has been connected to each of those modules where the sensors are mounted. Okay, one of the way is by using the wireless connection. Okay, and another way by using the Wi-Fi, by using the IIT Mondays intranet. So some of the sensors have been connected to the server base, our central location of the base database. All right. So here, basically, this is a simple thing what I was talking about as an application here. So now at each of the location, so some of the data which have been showed, so that is the resultant of these setup itself. So from each of the location, the temperature sensor, which records the temperature information at the regular interval of time, and the same interval of time, the humidity will be recorded by the humidity based sensors, and then pressure sensors records the pressure information, and like that, the different sensors collects those things. Okay, and each one in that module which is mounted on the Raspberry Pi, so they have this limited storage, and they store in the respective data has been stored there. Okay, and then at the regular interval of the time, the data which has been stored over there are transmitted to the central location where the database is existing. Okay, either through the Wi-Fi connections, sorry, the wireless connection through which they are connected, or through the Wi-Fi in the IIT Mondays intranet. Okay, so the data has been transmitted to the central locations, and in that location, all the data are are integrated to form one coherent data. All right. So if you look at this, is one of the sample data which is collected on the different dates and different time from the different locations here. So if you look into this, this is everything has been collected on the same date. Okay, but if you look into the packet ID, we are seeing here, so this is indicating the different locations from where that has been. Okay, sorry, this node address, what you are seeing here, it is the address or the location from where each one of the node is collected, and from there, from that particular node or the module of this Raspberry Pi, so from there the data has been collected, and then there is something like it's a voltage, okay, and the temperatures. And there are different temperatures at the different locations, and in the same places has been collected. Temperature 1, 2, 3, and the humidity value, the pressure value, you can see there. Okay. So now if you really see that when the process of integration and when the data has been collected, so due to some reason, some of the temperature values have not been recorded. Okay, you can notice here, right? So this is what we're talking about, the missing value. All right. So one has to take care before we put to use. So one has to address the issue of this missing values cases. Okay, and here, since all the care has been taken care, that's why there is no inconsistency in the data. Okay, now this data which has been collected, which is helping us. Sorry, I could not show you some of the plots associated to the visualization in the descriptive analytics, but still, so what the insights we are getting it from this data is that, so it is helping us to identify which part of the year we are having the lowest temperature, and what is the lowest temperature in a year, and what is the highest temperature in a year. And and as you know that in IIT Mandi we are in the Himalayas, so the temperature varies from the summer to the winter. Winter we are having the harsh winter, and then summer is a moderate. Okay, we can see that. Okay, if you look into take only the summer season. Okay, what is the average temperature over there? Okay, these are some of the analytics. This is easy to make. And what could be the minimum and maximum temperature? Okay, and also during the winter time, what is the peak and what is the which month it is a peak winter we had, and what is the trend of the winter is going for year by year. We can compare with respect to the previous year, and all these kind of predictive analytics, we are able to do that with respect to that. And then sorry, not the predictive, descriptive analytics, we can do that. At the same time, one can also do the predictive analytics by predicting, looking at the trend. Okay, what could be the temperature in the next 2 years, or sorry, not next 2 days. Okay, So 2 years is too much. So this is next 2 days. Okay, and these are the this is the main application of this particular weather station which we have set up. Okay, so the what I'm trying here is as an application here is that we are seeing that the entire data science process has been considered over there. Okay, right from deploying the sensors and then collecting the data from there, pre-processing there. Okay, and then put to use for the analysis and then making use of them for the various reasons. Okay, so that is what the one of the application which I have started. Okay. The second application, again, this is one of the major project IIT Mandi is involved, though I'm not the part of that, but that is the landslide monitoring system. As you know, the Himachal or in the Himalayas, so they often, it's a hilly area and often there's a lot of landslide reportings you are saying, right? And this landslide causes a lot of damages to the properties, okay, and the lives of the people, okay? So, the IIT Mandi has taken an initiative here to build a low-cost landslide monitoring system, okay, which can be deployed in the various slopes, in the various hills, okay, and regularly monitor the soil movement, okay, and then do the predictive analytics of analyze the data and what is the trend in the soil movement it is happening, and then if there is any chances of landslide, so warn it to the local people through the SMS or through the siren. Okay, so for that, so the landslide monitoring system, which has been IIT Mandi has been developed. Okay, so it's based on the Internet of Things and the low-cost micro electromechanical system MEMS sensors. Okay, and so the credits of this task is from the two of my colleagues, Dr. Varun and Dr. Uday Kala. So these two people, they have taken this initiative and then came up, they started this particular project. So the more details about this particular project or the landslide monitoring system, which IIT Mandi has been developed, so that you can get this from this website which I've been mentioned here, the www.iiots.in. Okay, so this is now they have started a startup company from this particular project, and this they have deployed this landslide monitoring system in various locations in the IIT in the Himachal and the and Himachal and neighboring states. Now they have been expanding to the other states also, like Maharashtra. Okay, so the point I'm driving here is that, so the important thing you are seeing here is that the two faculties who are who initiated this particular project here, the Dr. Varun Dutt, he's an expert from the computer science and machine learning background, and then Uday Kala, he is from the civil engineering, he's an environmental specialist. Okay, so this is the point I'm driving here is that data science is enabling the people to collaborate such that it's a totally all these data is interdisciplinary project or interdisciplinary scenario what you are seeing here. Okay, so if you look into this, so as I mentioned, this low-cost the landslide monitoring system, it is relying on the Internet of Things, IoTs, and the MEMS sensors. Okay, the different sensors which they have used in this particular case are, so they have considered the accelerometer sensors basically to look into the acceleration in which the soil movement is happening, and the force sensor, what force the soil movement happening, and then the soil moisture content, soil moisture sensor, and then the humidity sensor, light sensor to indicating the to record the intensity of the light in that area, and the temperature and the pressure sensors to record the temperature and the atmospheric pressures, and also tripping rain gauge. This acts as a sensor to collect the to record the amount of rainfall that is happening, and all these sensors collect these different informations, right? So these are the responsible for collective effect of these things are responsible for movement of the soil that leads to the landslide. Okay, so these parameters from the environment has been continuously monitored by these sensors, and these sensors are usually they mount it onto this GSM module, from where the collected data has been stored locally, and then it will be ported to the centrally located server through the cloud. Okay, so this is what I was mentioning. These are the various parameters of the atmospheric and the weather and the soil parameters that has been recorded in order to monitor the landslide, monitoring the landslide. Okay, so if you look into the architecture of this diagram, so all these accelerometers and the soil moisture sensors, and also it measures the tilt of that hill where it has been mounted. Okay, all these things are modeled in the microcontroller unit, which are mounted in the GSM. So the sensing unit senses the information, and they get recorded in the repositories, recorded in the small buffers that is present in the GSM module. Okay, and these from this GSM module through the wireless, okay, or through the through the wireless, so or through the cloud networks. So this data has been transferred to the server where the data is located in the IIT Mandi. Okay, and on these recorded data, when so remember here again, here all these sensors are independently the record set, they stored separately, and when they are transmitted and then they reach the IIT Mandi cloud. Okay, so there they get integrated, and then they a coherent database has been maintained, and on these data of this moisture and the soil content of the information, and then we put some threshold, and on those threshold, if it crosses some things, and it alerts an alarm. Okay, and this threshold computing and threshold comparison, for that they make use of the machine learning algorithms to see whether it is reaching the threshold. Okay, whether we can predict the happening of the landslide from the movement of the soil. Okay, and then we can generate an automated alerts to the people neighboring over there. Okay, these alerts are given through the traffic lights, or through the SMS, or through some other through the mobile informations. All these things it is being done. Okay, so this recently this particular system has been this has been taken by the state authorities, and then the several deployments are already done in Himachal Pradesh and Uttarakhand states. And they recently say the requirement has been placed by the Maharashtra government to deploy in there also. Okay, there are a lot of success stories are there where successfully these systems have identified the landslide. Okay, so for making the predictive analytics of the movement of the soil. Okay, so they have used the latest this LSTM based time series prediction. They are doing it. The one such plot you are seeing here. Okay, so this can predict for few hours ahead that the possibility of the landslide from all the parameters which has been considered. And there are a lot of success stories are there. They saved several lives by giving these predictions. Okay, so this is the one of the true sense of data science related applications, where it take care of collecting the data, making the prediction before that, pre-processing and all the things. Okay, so this is the one of the application which I was like to given it to you. Okay, and giving it to you so that the kind of a work which we are doing here, what kind of a data science applications which we are doing. Okay, that's the one thing. And the final thing, what I'm going to see is in which year I myself has involved in this particular project. Okay, and in this one, it is totally a true sense of data science product, where the data analytics, big data analytics, we have done that, but we are doing it on the network management system on the large telecom networks. Okay, and this particular project, it is a part of the project which has been sanctioned by the MHRD's Uchatar Avishkar Yojana under that particular scheme. And this project is in collaboration with our industry partner, is the NMS Works from Chennai. Okay, so this NMS Works, it's one of the leading network management company, so which provides the services to various telecom service providers. Okay, and this NMS Works is located in the research park of the IIT Madras. Okay, so this is the project in association with that. Okay, there are various other faculties in IIT Madras also involved. It's a true sense of interdisciplinary cases. So where as a machine learning expert, myself, machine learning and data science expert, myself, Dr. Varun Dutt, and then Aditya Nigam is a part of that. And apart from that, Professor Gonsalves, he is as an expert of the network and telecommunication expert, he is a part of that. And then Dr. Sriram, he is involved in this as a part of the big data, so as a part of the distributed computing expert. Okay, so because this particular thing, it's a very real time and a huge data that needs to be handled, and the processing has to be happened in a distributed fashion where the different technologies to handle such a huge data in the real time, that is required. That's where the Sriram's work has come into picture, and doing the analytics and designing the things. So, and the predictive analytics where my expertise comes into picture, and how these things to be taken into the telecom network domain. That's where the Professor Gonsalves' expertise has come into picture here. Okay, so that is the main thing. Okay, so just to understand this is what are we trying to do in this network management system for this thing is that. So in this particular project, we have concentrated only on the broadband network based devices only. Okay, so basically, if you really see that there are several hundreds of thousands of subscribers are there, they usually connected to the digital subscriber line modems, which in turn is connected to the DSLAM access multiplexers, okay, which in turn connected to the resilient packet rings. And several of these resilient packet rings, they are connected to the PNG devices. They are nothing but the broadband network gateway. Okay, so these broadband network gateway, they acts as some kind of authentication server. So where the subscriber through these intermediate devices, they log into the network. Okay, they are authenticate the network. Only the authenticated customers, they can get the access of the network. Okay, this is how that broadband system, the networks in the telecom network field, that will be working. Okay, so now if you really look into this, so this here we are dealing with the data from all over India. There are millions of subscribers that are involved in that, and at the same time there are hundreds and thousands of millions of these managing devices like PNG device, RPR, DSLAM, they are there. Okay, and basically what are we trying to do in this project is that we are trying to analyze or monitor the health of each of these managing devices, so that to see that any anomalies or any kind of alarms which will be raised, that will bottleneck the performance of each one of the things. Okay, basically for the smooth and errorless functioning of the telecom network, so we need to, that's a very important aspect, we need to monitor each of those millions of managed objects like your BNG devices, RPR devices, and other things, and we need to observe them that okay, they are not down, or they are functioning completely continuously for 24 hours and 365 days. Okay, if they are down or if they are not functioning properly, then we need to find what is the root cause for that, and is there any excess of the bandwidth what is being sharing by them, or the utilization is too much. Okay, because of that the devices are not functioning, then what action is to be taken. All these things are the part of that. Basically, these networks are managed by these network management systems. Okay, and to find out any of the anomalous behavior are performed by these. Any anomalous behavior that leads to the disruption of the services to the customer. Okay, so this proper monitoring helps us to take a necessary action before the any of this anomalous behavior they can get into. For these things, so this network management monitor, they monitors and stores the data from the different network devices. So what are these data? Their data associated to the KPIs. KPIs means key performance indicators. Okay, and these key performance indicators, something like the what is the CPU utilization of that, and what is the memory utilization of that particular device, and also what is the bandwidth utilization. All these things are the performance indicators. Okay, when they cross a certain threshold, or when they go beyond the certain threshold, then that's indicative that, so these are performance measures are the bottleneck for the services, and this may tend to make the device down. Okay, because of that, the service may be interrupted. Okay, so we need to predict those things well ahead as a part of this. Okay, that is the important aspect. So that's why the predictive algorithms to foresee these performance bottlenecks is very much important in this network smooth functioning of the telecom networks. Okay, so as a result of this, the main goal of this project is to develop the next generation network monitoring approaches, which includes the sophisticated data analytics in that. Okay, so this network management monitoring system, it is one of the version is already existing with the company, but they do not have this data analytic feature in that. Okay, so where that is the responsibility of us to develop that data analytics things in this network management system. So that is what is the thing. Okay, so in order to do that, there are multiple goals that we need to be set. That's one of the things is that the data what we were handling here is a real-time data. At every interval of 15 minutes, the stream of data associated to the performance metrics of each of the devices is coming, and we are not dealing with one device or two devices. Say millions of devices all over India is coming to the database. It's a real-time and huge data is coming from all the places. Okay, we need to have a scalable architecture that stores the data, pre-process the data, and make it ready for doing this analytics. Okay, so that is where is one of the goals to come up with. Okay, that is why the big data analytics, but the framework for handling that big data that has to be come up with. It is not a static data. It is, remember here, it's a stream of data. It is continuously pumping up. And the second goal in that is to analyze the data which has been collected on this performance of the various type of the network devices, and then they look into the alarms or the faults which is rising from that, and come up with an efficient visualization for this telecom network data for doing the descriptive analytics. Basically, to do both the predictive analytics as well as the descriptive analytics on this data. That is what is the goal. Okay. So I'm not going detail about the technology and techniques that we use. Then just I'm giving you the insight that, okay, so what are the things are involved in the big projects where the data science project is involved over there. Okay, so as I mentioned, so the continuous stream of data has been coming in. Okay, and so we need to we are concentrating on the high priority alarms that has been generated due to that. So for that, see the data which has been collected, it has to be formatted. It needs to remove some of the duplicate entries, remove some unwanted features, pre-processing has to be done. Okay, and for doing all these things, we need to have a distributed streaming processes so that it has to happen in a real-time scenario. That's exactly the reason why our experts from the Sriram and his team, so they came up with a Kafka-based architecture. So the scalable architecture based on the Kafka, Apache Kafka and KSQL as a distributed streaming platform. Okay, what they do is that from the multiple data sources, the data data acquisition is done, and then they do the data enrichment, and then they stored in the MongoDB. Okay, MongoDB is the database is being considered for storing the data. And then from the data as it is coming to the database using this distributed streaming platform, it uses to clean the data. Okay, by removing the duplicate and unwanted data. And then so there each of the performance metrics are coming separately as a separate table, and they are aggregated. Okay, and then they integrated to form a coherent data store, which is suitable for using it for the machine learning algorithms to make a predictive analytics. Okay, so when this stream of data which has been collected, so the some set of the data they will be sent to the offline machine learning model training process. Okay, and the trained model will be stored in the backend server. Okay, for making the predictions. Okay, and at the same time, the stream of data when it comes to the distributed this platform, it cleans the data and make it suitable for making any predictions or to making any analysis. okay, by removing all the unwanted information, noise and everything. And then they is given to the backend server to make the prediction. Okay, so we have a Signet dashboard. Okay, Signet is the name of the device or name of the product. Okay, and the dashboard is running on top of these distributed platform. Okay, where in the which is running in the backend server, where whenever this stream of data comes, they make the predictions either by using the machine learning algorithms or some kind of a the insight of the data can be obtained by using the descriptive analytics. Okay, this is the overall framework which we were talking about. Okay, so basically the data pipeline, it feeds to the dashboard for the model predictions, and these are integrated by using the REST API libraries. Okay, that's how we have designed it. Okay, so now here there are two goals are there. Okay, so the data when we were considering here. So there are 15 key performance indicators we have considered. So the active count indicating the what is the we are concentrated on the BNG devices, the health of the BNG devices. Okay, so the active count indicating the how many the users have been attached to this particular active at that particular time, and then the disconnect count, CPU utilization. These are the various performance metrics of that particular, and the temperature present over there, and what is the input bandwidth, and what is the output link bandwidth. Okay, what is the packet per second transmission? All these things are collected at the interval of 15 minutes, and then it is at each that interval the data is pumping into the system. Okay, so that is the kind of a data which we're having here. Okay, so our major goal is to basically the data what we consider is from the tier 1 telecom service providers, which is handled by our NMS works. Okay, so okay, so there are two things we are doing here. One is we are trying to find the health of the devices to see that, okay, what is the performance metrics, how they are behaving for at each of the time. And the second thing is that, so is any misbehavior in that may lead to the alarms. Okay, there are 69 different alarms are there in the system. Okay, we considered the 7 key alarms to predict based on the performance metrics which we were monitoring. Okay, so there are these 7 which I mentioned over here. Okay, so basically the end-to-end alarm predictions what we have designed is in the 2 phases. The first phase, we do the multi-step ahead prediction of the performance measures. Okay, we post it as a time series prediction based on the prediction what it does by the performance measures or performance metrics. Okay, so then we identify whether it leads to an alarm or not by using a classification framework. Okay, so basically the key performance indicators which are at the interval of the time of 15 minutes. So that has been given to the prediction model. It predicts the n step ahead prediction. That means the future prediction of that particular performance matrix is does. Okay, if that is there in the desirable range, then the alarm prediction model which classifies whether it leads to an alarm or not, and if it leads to an alarm, what type of the alarm, what of those 7 alarms. So that is what it calculates. Okay, that is the predictive analytics which we were doing as a part. Okay, so and this is the dashboard which I was talking about. So in which the various predictions what you are seeing here that you can see the different the kind of a different predictions on the different metrics like CPU utilization, memory utilization, temperature of the device, and then active count, and all these things predictions will be done. Remember here, this dashboard, it is running on top of the the distributed platform which we have designed. Okay, so that handles the real-time streaming of the data. Okay, so what I'll do is that, So these are some of the prediction results which I'm showing over there, and the accuracy with it at the accuracy of 95 to 97% accuracy, it detects whether the future prediction is whether it is lead to an alarm or anomaly or not. Okay, and there are and the alarms which have been predicted have been kept it's given as a live feed to with respect to the different locations. All right, and there are various data exploration and visualization techniques also being used over there to understand data. Okay, so yeah. So what I'll do is that I'll just there is a one small video and 4 minutes of video demo which shows the various features of this particular application where it has been following the various approaches of your data science, what I discussed so far. Okay, so with this I'll conclude my session, and let's just try to listen to this video. Is it audible to all of you?
ICCIDS dashboard is an online tool for real-time network data analytics. It's
Yes, sir.
Is it audible?
Yes, sir, it is audible.
Use machine learning algorithms as a black box and utilize them to proactively avoid faults in the network. It also provides powerful visualization tools to perform statistical analysis on data.
Sir, the volume is very low, sir.
Okay.
And data exploration. Homepage gives a geographical view of various.
Is there any way to increase the volume or something?
Is denoted by a marker. Single click on a particular marker allows us to see its device details and topological position. Double click on each marker reveals the devices it is connected to. Admin panel is designed to contain the widgets of important features of network data such as CPU utilization, memory utilization, temperature, active count, link utilization, and alarms. Predictive analytic tools allows us to predict the future values of these features. Gearbox at the top of each widget allows us to select the IP address and model we want to use for prediction. The dashboard is connected to various univariate and multivariate statistical and machine learning models to perform one-step and multiple-step predictions. An admin can see and change these settings and apply them by clicking on Save. Once the settings are saved, the predictions on real data are triggered. On clicking the widget, we can see the live plots on streaming data and corresponding predictions.
This is actually the live prediction which is happening there.
For alarm prediction, the features of network data are predicted and fed into a classification model. Save the settings. The alarms are predicted and are visible on the live feed tab at home page. As and when an alarm occurs, it is updated on the live feed tab. Predictive analytics is so powerful but is prone to error. However, numbers never lie. Hence, on the data exploration page, we provide powerful visualization tools to analyze our data. Once we select the settings for parallel coordinates graph, it shows us multiple dimensional view of network data. It allows us to perform if-else analysis on the go. We have extended its functionality to show pie chart of a particular feature. It can also perform linear regression between any two variables. At the end, it shows a correlation matrix between all the features. Highly correlated features are highlighted in the correlation matrix. Bubble chart is a four-dimensional visualization with link utilization in x-axis, number of alarm transition in y-axis. The location is denoted by color of the bubble, and size of the bubble denotes total downtime. Network data may be dependent on external events such as holidays, sports, natural calamities, and political events. Effect of these events are highlighted with the help of box plots that help us analyze the average and extreme values of feature of our interest. Stacked bar charts allows us to visualize the breakdown of different categories of alarms such as threshold alarms, communication alarms, equipment alarms, and device manufacturer alarms. Overall, this dashboard is a one-stop solution for all the woes of network administrators. It assists them in taking well-informed decisions backed with powerful statistics and predictive analysis. Thank you.
Okay, so yeah, this is all about my talk also. So basically, I highlighted basically what is data science and what are the components that's involved there, what are the tasks involved there, and how that helps. And with reference to some of the applications, I just try to give a glimpse of what are the things involved in building any of the data science projects is associated with it. Okay, so that's what from my side. Okay, I'm open for any of the questions or queries by this. Okay, thank you.
Participants, do you have questions?
So
Sir,
there's
I have a question.
Yes, sir.
Yep.
Sir, I have a question, sir.
Yep.
So right now the concepts of metaverse, blockchain, and NFTs are on the rise. So I would like to know how data analytics can play a part in improving these technologies.
Okay, see, the thing is that the blockchain and all these things are associated with something like your security giving the things, right? All right. So wherever you have the past data, and then wherever the possibility of the processing it and then making the things better, so there's all the places the data science is being used. Because I'm not an expert in the those areas where you are mentioned, but with the limited knowledge, what I'm having and what I mentioned is that all these things depends upon what data what you are having there. Okay, so the machine learning algorithms and this especially the machine learning algorithms, they always helps in making these systems much robust. All right, so in that sense the data science is it's helping them. Okay, only that's what I can mention in this.
Thank you, sir.
So there is a question in the chat box by Professor Chitra Babu. In this narration, it says data never lies. However, can you comment on the saying, if the data is tortured long enough, it will confess to anything?
Yes, I totally agree with this. Okay, see the comment what I mentioned, data never lies. That is the data which is collected, it gives a true picture of what is happening in that device and what is happening over there. Okay, so and if you say that, okay, when it is tortured for long enough and then it confesses anything, so it depends on how the learning algorithms have been used in order to do the things. Okay, see, in a way, what I treat is that if you torture the data long enough and then confess anything, so I consider this as a kind of a problem of overfitting your training model. Okay, so that is a common problem in the machine learning. Okay, where if it gets overfit, then it just do it with respect to that training data set what is talking about. Okay, not to the unseen data. It is not doing anything. Okay, that's exactly the reason why. So when we are trying to use the machine learning algorithms, we try to regularize it such that we are not building the model which is overfit. Okay, that means that it is listened to only to the training set. That means that that is the set which has been used to torture the data, but we can say that. Okay, and it is listening only to that. Okay, we need to make it so generalizable that it has to listen to the unseen data, which also give the true picture of the things. Okay, and all the goal of the machine learning algorithms nowadays, we are trying to see that how much the data, the model built is more generalizable about. Okay, and we are following the lot of techniques that ensures that. Okay, so hope the question is answered, I think.
Yes, sir. Thank you, sir. There's another question from Dr. Bettina Anthony. In terms of profession, how are data scientists different from data analysts?
Okay, so there's a thin line difference. There's a difference is there here. So what I believe is that the data analyst is the one who analyzes the data and who is make use of some of the black boxes to take the as an aid to analyze and understand what the data is there. Okay, but the data scientist, his responsibility starts right from the beginning stage, where he tries to build a system which is more suitable to design, so that can help the data analyst to work well, or to make the prediction better. Okay, so that is where I am seeing this as a two differences. Okay, all right. So hope the answer is conveyed, I think.
Yeah, thank you, sir. Audience, you can even unmute yourself and you can
just to add to the same question itself. So the what I can say is that, so I have mentioned these two projects, right? So we are the data scientists. Okay, so we designed the system using the techniques which designed by ourselves to make some predictions and then analyze on the telecommunication network. The people in the NMS world, they are the data analysts. They use these techniques, the product which we built or the technology built by us to make the better understanding of the data or analysis of the data. So that is the difference you can see now. Okay, right. Okay. So any other questions are there?
Yes, sir.
Yeah.
Sir, I have a question. Like, what are the technologies that you can look up to for analysis or predictions? Sir? What are the recent things that are coming up that we can look up to?
Can you just say again? What is exactly the thing?
Like, what are the recent technologies that we can look up to for data analytics or prediction analysis? Sir?
The recent technologies. So in one sense, you can see that I don't have one answer to that in that way. So the data analysis, it's always a growing things, and it is always and also it's a field of creative things. So how well, these are two things we are there here. How well you do the descriptive analytics, where you will be making use of the statistics to understand more and more in that. Okay. So the technology which you're going to see there is that how well you present the data and what are those the graphical presentations, some of the things which I've mentioned over there, right? So how well you present the data, that is one side of it. And another side, if you looking into the predictive analytics is concerned with, the recent technologies is associated with the deep learning as techniques which are suitable for the given data is concerned. Okay. So I'm not specifically saying that this is the technique useful for this, this is the technique useful for this, because there are a lot of the recent deep learning techniques are there which are suitable for this. But all these things in association with what kind of a data you are having, and with respect to that, it is applicable. Okay, I can only answer only at this level. Okay.
Thank you, sir.
All right. Yeah.
Sir, I have a question.
Yeah.
So like with many companies and research labs like focusing on building quantum computers and like IBM and Google, How will the field of data science and data analytics be affected if quantum computing becomes like a mainstream reality?
See, the thing is that this data science basically what we are processing the data, right? So it requires a lot of computations involved. The better the computation, what you are coming up with, so the better the algorithms that can speed up the process of processing the large chunk of data and other things can be possible. Okay. See, you can just see that if you want to use the deep learning techniques for the huge amount of data, so you need to have the good computation with the GPUs and other things are coming there, right? But if the quantum computing comes into picture where the computation can be done, the large computation can be done in the real time, obviously all these techniques which is involved for doing these pre-processings, then they get they get benefited. Okay, this is what my view in that way. So it's always, you can see that it's a positive effect will be there. Okay.
Yes, sir. Thank you.
So any other questions or anything? Okay, sorry, I think there are some noises are there. I think, I don't know how much it has been affected in the last part of the...
No, sir, your talk was very clear only, sir.
Okay.
We could get your points clearly.
There are some construction noises happening here, just started. So, I don't know. So that, all right. Okay, so
Yes,
any more questions or anything? Yeah.
Okay. Thank you, sir. Thank you so much for your insightful speech on data science and its application. You clearly explained the types of data used for data science, and you also covered the need for data pre-processing. You have also made the topic predictive data analytics more clear to the audience, sir. Then your explanation on the real-time applications on the research work going on in IIT Mandi was very inspiring to us, and we are all motivated to do research on data science projects. We hope the participants would have found the session more useful. Thank you so much, sir.
Okay, thank you. So yeah, I'll share this lecture material in the form of this thing. So anybody wants to contact us, anybody wants to have any more interactions and other things, they can mail to me. Okay. So
yes, sir.
Okay. Dear participants, thank you for your undivided attention and passionate engagement. Please make use of the link given in the chat box to fill out the attendance and feedback form for the current session. Thank you. We will again meet in the next keynote address at 1:30 p.m. Now we will break for the paper presentation track. Thank you. Thank you, sir.
Okay, thank you. Thank you all for giving me an opportunity to discuss with you people.
Thank you, sir.
So I'm hoping more such interactions in the future.
Sure, sir. Looking forward, sir.